Okay, so let's look at one of these. We have a 2,000 kilogram semi-truck, so mass is 2,000 kilograms, traveling at 9.4 meters per second. So V, I'll call this M1 and V1, equals 9.4 meters per second. To the right, collides with a 1,200 kilogram car. Mass 2, actually, can I get, yeah, mass 2, 1,200 kilograms, initially at rest. So that velocity 2 equals 0. So right away, I can start doing the momentums for the car, which would be 0. And the momentum for the truck would be like this. Grab the calculator. Mass times velocity. Anytime we do this. Back to this. Mass times velocity. So 2,000 kilograms, 9.4 meters per second excuse me. Gets me 2,000 times 9.4, 18,800. 18,800. So back to the mouse, 18,800. Huzzah. So after the collision. All right, so what else do we know here? After the 0.8 second collision, so I have a time equals 0.8 seconds. The semi-truck continues moving to the right at 4.5 meters per second. So the truck, V1F for V1 final, 4.5 meters per second. Okay, so I can get a momentum again. Back to my, it's the same equation, mass times velocity, so 2,000 kilogram truck times 4.5 meters per second equals 9,000. Okay, and then back to my mouse. 9,000 for the truck. That's what it gave us. Okay, so if I want to know the impulse, right, impulse is equal to the change in momentum. So I can look at the change in momentum of that truck. It ended up being 9,000. It started off at 18,800. So it's always final minus initial. So that gives me a negative 9,800 kilogram meters per second. And I'm pretty sure this won't let me put in any negative values because, well, I'll talk about why in a second. 9,800, score. Okay, so that's my impulse. Also my change in momentum. For the truck, that's going to be negative because there's a force pushing backwards on it. But for the car, that change in momentum is going to be positive. Back to blue for the car. So the change in momentum for the car. So it was 0. So now it should be 9,800. And it is. Huzzah. How fast did the car move after the collision? Well, if that's its momentum now, which we just figured out, is 9,800 because that was the impulse and the change in momentum. And that's the same for both things in here. That momentum, I move my face, equal to mv. This is v2 final. So the momentum of the car, 9,800 equals a mass of, where did I find it? 1,200. V2 final. Last but not least, divide by 1,200, divide by 1,200, and I get V2F equal to, where's my calculator? There it is. 9,800 divide by 1,200, less than 30 seconds, 8.17. 8.17. And back to the pen, 8.17. Huzzah. What is the magnitude of the average impact force? All right, so in the 10 seconds I have, I'm not going to be able to do that, but I have the impulse, which is 9,800. That's going to be equal to the force times the time, and I have the time.